Hello guys, how are you? Welcome to Cosmic Essence Education. I am Maitray Agrawal and today we will be looking at functions. So let's get started. Okay, so now let's start with functions. So first we look at the definition of functions, and I want to tell you one thing about definitions which is quite important, is that you do not question what a definition for something is. Okay, a definition is something that we give ourselves to define that thing, and upon that definition is built the other things. We build the other things on that. So definition is the starting point, and we do not question what the definition is or why is it like that. It's just that the definition should be so good that it should help us in the future cases. So let's start with functions. Now we've already done relations, so let's start. A relation is a function if all the elements of the domain have a unique image in the codomain. This is the definition of functions, and there are two important parts in this definition. Okay, first, a relation is a function if elements of the domain, all the elements of the domain, this is the first condition, all the elements of the domain have a unique image in the codomain. This is the second most important condition for a relation to be a function. Okay, there are two conditions for a relation to be a function. First is that all the elements of the domain should have a unique image in the codomain. So the two conditions are very important. How do we write it? I define, say, I'm defining a relation here first, f from set A to set B such that y is equal to f of x, where x belongs to the set A and y belongs to the set B. Now this relation is just a relation right now, okay, but for this relation to be a function, these two conditions should be satisfied. Okay, so let's look at the different parts of the definition, and then we will make sure that this is a function. How do we make sure? So now a function, say this is a function f, this is defined from set A to set B. Okay, so first set is A, second set is B, such that y is equal to f of x, where f of x is an expression in x, in the variable x. X is known as the independent variable and y is known as the dependent variable. Now this expression in x can be any mathematical expression. Say it can be x square plus 2, or it can be 2x plus 1, and so on. So in the expression we take x as the independent variable and y as the dependent variable. Okay, if I want to visually represent this, this is set A, this is set B. I am defining a function f. X is an element of A, y is an element of B. They both are related under the function f if y is equal to f of x. Alright, now y is equal to f of x. This is known as the image of x under the function f. Under the function f. X, which is the element of the set A, which is the independent variable, this is known as the pre-image of y under the function f. So these are the important quantities or important definitions that we have to know first. Okay, so now let's go a bit further. I'm making the function using the visual representation. This is set A, this is set B, and we're defining a function f. Suppose the set A has a few elements, and the set B also has a few elements. Like this. Now, all the elements of this domain, this is known as the domain. The first set is known as the domain. The second set is known as the codomain. All the elements of the domain should have a unique image in the codomain. Suppose this is how we are defining the function. Now, this set is the domain, and the second set, in the second set, the set of all the images, is known as the range of the function. This set is known as the range of the function. The free elements here are a part of the codomain. They are not part of the range. Okay, so the codomain is the complete set, and the set of images is known as the range of the function. Okay, so now let's look at it further. So suppose if I ask you, this is set A, this is set B, there are some elements here, say x1, x2, x3, x4, and there are some elements here, y1, y2, y3, and they are related in this manner. Like this. So if you see carefully, x1 is related to y1, x2 is also related to y1, x3 is related to y2, x3 is also related to y3, and x4 is related to y2. Now, if I ask you the question whether it is a relation or a function, can you give me an answer? This is a relation only. It is not a function. Why? Because it doesn't satisfy our conditions for a function. If we look at this element x3, it is having two images in the codomain. It has y2 and y3 as the images. Because it has two images, there is not a unique image for this element, and that's why it is not a function. Though it is satisfying our first condition that all the elements of the domain have an image, so it is satisfying that condition, but the second condition that it should have a unique image is not satisfied. That's why it is not a function. Now, you may think that these two elements also have an image which is the same, but we do not have a problem by that. What we mean by unique is that one element should have only one image. Only one image. Two elements having the same image is not a problem for us. It's just that one element should not have two images. Two or more than two elements can have the same image. It does not affect, or it is not a problem for us. Okay? So this is a relation. It is not a function. If I take one more example, suppose like this. This is a function. It is a function because every element here is related to one image. Every element here has one image here, and there is only one unique image, so no problem, it is a function. If suppose I add it like this, then it becomes a problem. This element has two images, and that's why it will not remain a function. Okay. Let's take a few examples. Also, you may have noticed that a relation is a function if it satisfies the conditions. Okay, that means that every function is a relation, but every relation is a function is not true. Okay, so a function is a relation, may be a relation, a function is always a relation, but a relation may not be a function. Okay, let's take an example. Say I am defining a function f that is from the set of real numbers to a set of real numbers such that y square is equal to x and y both belong to the set R. Can you tell me, is it a relation or a function? Well, because if we look here and we observe that if x is equal to 4, then y can have the values plus 2 and minus 2. That means x, which is the independent variable, will have two images in the codomain, and that's why it does not satisfy our condition, and it is not a function, it is a relation. If I change it just a little bit, say I am defining a function g from set R to R is the set of real numbers, such that y is equal to x square, x and y belong to the set of real numbers. Now if we look at this function, yes, it will be a function, this is a function, because it will satisfy both our conditions. See here, for all values of x there is an image possible. For all values of x there is no value in the set of real numbers whose square will not exist. Okay, so that means that all values of the domain have an image, correct? Also, for all different values of x there will be a different value of y, so x will always have a unique image, so second condition is satisfied. That's why it is a function. Let's see if we can tell whether it is a function or not from the graph as well. We can use the graph as well. So if I draw the graph of this function, the graph of this function is a parabola like this, facing right side. This is x-axis, y-axis. Now if we look here, we can see that for one value of x here, there are two values of y possible, one here, one positive and one negative. So from the graph also we can tell whether it is a function or not, and that itself is known as the vertical line test. The vertical line test says that if in the graph of a relation, if a vertical line drawn anywhere intersects the graph at 2 points, a vertical line drawn anywhere intersects the graph at 2 points, then it is not a function, otherwise it is. So since here this line intersects the graph at 2 points, it is not a function. Let's make the graph of this function. The graph of this function will be a parabola facing upwards like this. Now if we look here, I can make vertical lines anywhere and they will not intersect the graph more than one time. They will always intersect only once. So this passes our vertical line test, and that's why we can say that this relation is a function. It is a function. Got it? Okay, now let's take one more example. Say I'm defining a function f from the set of real numbers to a set of real numbers such that y is equal to sine x. X and y belong to set R. Now sine x is a function and we can see that from the graph as well. The graph of sine x is like this. The maximum value is 1, the minimum value is -1. Now, if we look at, or if we take the vertical line test of this graph, the line will never intersect more than one time anywhere. So it passes our vertical line test. It means that it is a function. Okay. The domain of this function is the set of real numbers. This is the domain. And the range is the set of numbers between -1 and 1, because these are the only possible values of y. So the range is the set of closed interval -1 to 1. This is our range. That means all values between -1 to 1, all real values including both -1 and 1. Okay, so we looked at the definition of functions today. If you like this video, don't forget to hit the like button and subscribe by clicking on the bell icon, and we'll be coming up with more videos just like this. So thank you.